Okay, so now in the second step, we want to determine the fault current at each of the load bus. So we will begin at the lowest bus, bus C. So when you want to determine the fault current at bus C, so one thing you have to recall is the Thevenin theorem, because the load at bus C, the fault at bus C is modeled as an impedance, right? So from Thevenin theorem, we know that if the impedance changes at one particular part of the circuit, we can reduce the circuit by using Thevenin theorem, so that we can reduce the circuit into only two elements, which is all the remaining part of the circuit that is fixed as one impedance, and the varying impedance at one part of the circuit as the Thevenin impedance, right? So if we can do that, then we are able to analyze what is the fault current over here. So the same thing here, by applying the Thevenin theorem, looking from bus C upwards, because that is where the fault happened. The fault can be at any level, and various levels of fault will give us various fault impedance value. So starting from the top, we have Vs, right? Vs in per unit. Okay, we have a voltage source, and then we get Zs, Zc1, Zr1. These are all in series. Why do I put that in series? Because, right, Zs here, and then Zc1, and then Zr1. They are all in series. And then when you come to here, Zc2 and Zc3, can you see that they are both in parallel? Therefore, Zc2, Zc3 parallel. And then you meet bus C. So at bus C, then you have a fault here, right? So the bus C, the fault impedance will be, I put this as bus C impedance. So this bus C impedance are the impedance that is varying. So by using Thevenin theorem, I want to determine what is the ZTH looking into the circuit from this direction. So I can, if you remember from your Thevenin theorem, the ZTH is calculated as switching off all the independent sources. So I switch off all these and open this circuit up, and then calculate what is the impedance of the circuit. So the impedance of the circuit will be this all in series, sum up with the parallel of these two. That will give me 2.4835 per unit. Okay, and then the VTH, what about the VTH? The VTH will be the V open circuit, okay, looking into the circuit from bus C. So V open circuit, no current flowing, so these two voltage point will be equals to 1 per unit. So as such, so the fault current at bus C will be taking the VTH divided by the ZTH. So 1 divided by this, you get this value per unit, okay? 0.4027 per unit, and that is equal to 10.6 kilo amp. So how do I get the base value of the current? So easy. Initially, we take the per phase, right? This is a per phase analysis. Therefore, we take the per phase base power. So the complex power, the three-phase complex power is 500 MVA. So the single phase divide 3, we get this. And then you want to get the per phase base voltage value. So it's equals to the line to line, per phase of the line to line. So per phase of the line to line is hard to get. So we convert the line to line voltage into the line to neutral. So we get this. All right, we get this. We get this value. And then by having S and the V, then we can determine what is the I already, because S equals to VI. So if S equals to VI, I will be equals to S over V. So we take this, divide by this, and then we get our base value of our current on the per phase basis. So we take this value, multiply this, we get this. So remember, the base value of the current that we are calculating has to be on a per phase, because when we do this analysis, this is the Thevenin theorem analysis. When we perform this analysis, this is on the per phase analysis. Therefore, you have to get the base value of the current on a per phase basis as well. All right. So let me see. Did I leave out anything? Mm. Right. Yeah, one thing I want to add on is this thing, right? You are given the line-to-line voltage 11 kV. Line-to-line voltage 11 kV. That line-to-line voltage is also the per phase voltage, right? Line-to-line voltage is also your per phase voltage. Imagine your delta. If you have a line-to-line voltage, line-to-line voltage is also your per phase voltage. So you just simply take the 11 kV, convert